Okay, so this is going to be my video on making a skateboard in Autodesk Inventor. So the project that you should be working on, or that you are working on, or my students are working on, whoever's watching this video, is reverse engineering a skateboard for a customer. So we're trying to reproduce an existing skateboard. And this is kind of one of my favorite projects at this point, just because it takes into a lot of different aspects. There's a reverse engineering aspect of it. There's, you have to have some creativity in the reverse engineering to try to figure out some of your numbers. And then there is the figuring out how to actually make it in Autodesk Inventor and then translate that into the real world, whether you're CNCing it or whether you're using a laser cutter to make your mold, or whether you're just using the measurements from a mold that you make. But this video is really designed to get to this part right here. Like, how do you actually make that skateboard and make those curves in Autodesk Inventor and make the placement for the correct holes? So just a bit of a caveat here. I am not a skateboarder. I'm not an expert in skateboarding. Some of the measurements may be a little bit off. Like, you can see how in my notes right here, I have 2 1/16. Last time I checked, that was just supposed to be 2 inches, but I took my straight measurements off of the skateboard we were working with. And so they may have drilled it off. I mean, 1/16 off for somebody hand drilling something is really not that far. So if you're like, oh, I can't believe you did that, well, it's because I'm, in some cases, guessing here. But we're going to go through the process, and if your measurements are a little bit different than mine, it'll come out in the end because the trucks won't fit, and then we'll have to go back and figure out the placement. So if my measurements are not 100% accurate, please be forgiving of that and make your own measurements and place those measurements in there. So I've gone through and I've kind of taken some measurements of what I think are important for the skateboard, and you can kind of also see that I've gone through and made some corrections on some of my math to figure out some of the angles. So yeah, in any case, let's get started. So our end goal for this video is going to be a product that looks like this. And so we're going to start off with a new part file. And we're just going to say a new part. And then we're going to start with a new sketch. And in this video, you're going to see me create and build on previous measurements. It's not really a fully parametric. Design. Like, you're not going to be able to go through and just put in like 2 or 3 numbers in and change the whole design of the product. But what you are going to be able to do is change the things that you will need to change for when we make the mold of this, the molding parts for the particular skateboard that we're working with. So in this video, I'm going to start in the XY plane just because that's kind of the plane that everybody's familiar with. But you don't necessarily have to. And all of the measurements that I'm using build on this view right here. So my section of the skateboard. So it's built on a radius of, or I'm sorry, this would be a radius of 23 inches, and then we go from there. So so first of all, I'm starting with a sketch, and I'm going to start off with 2 lines. Okay, and those lines are going to be parallel to each other. So I'm just going to make them straight up and down. Okay, and I'm going to purposely not make them level with each other. And the reason I like doing this is because I like to put in my own measurements of it to make sure that they are actually level. Yes, you can do it a different way. There's a million ways to do things in Autodesk. But again, I'm doing it this way in particular because of making sure that your measurements are actually in there. So the first one I'm going to do is I'm going to actually make sure that this one comes out to be 0. So those 2 top points are 0. I know it because I put the measurement in there, right? Like, I physically put that measurement into Autodesk Inventor, and I'm just going to move that measurement out of the way a little bit. Second one I'm going to do is I'm going to hit dimension, and I'm going to do this guy, and that should be 0.5 inches. And then this is where you've got to start building parametrically, because if you change the thickness of your board on one side, you really want it to change on the other side automatically. There's not many boards out there that you're going to really do different thicknesses of, just because you have a certain number of plies that you're working with, and in this case, we're building with, I believe, 7 plies. So we're going to start off with our first parametric measurement here, and that just means that it's equal to something before it. And so now when I change this 0.5, I'm changing this 0.5 as well. And then and I'm getting that measurement from the thickness of my board. Let's see, where did I write that down? Somewhere in here. I can't remember exactly where I wrote it down, but I wrote it down and I measured it at 0.5 inches. Then I have the width of the board. Okay, so this is going to be the measurement of how far across that board is. And so in this case, I'm looking at 7 3/4 inches. So this is how wide the board is going to be. And again, we're building the cross section of this board at this point. And I'm going to zoom out and kind of center it back in, building the cross section of this board. And so just if you can't see where I'm going with this yet, you will in a little bit. So just follow these steps with your measurements. So again, I'm pulling that 7.5 from the width of the board, this measurement right here, so all the way across the board. And then I'm going to put in a curve. So this is where, or an arc, all right? So my first arc is going to attach to the bottom of that line, and then I'm going to bring it over. Let's zoom in, make sure we actually get on it. And then I'm just going to put that arc in there. It's not the right measurement. I'm going to come back and put a measurement in on it later on. So again, I'm going to measure this one out. It's going to snap 2. Okay, so I've put to the top of that. And then I'm also going to go to the top of that. And again, I'm not getting it exactly right now, because I'm going to go back and I'm going to put it in right now. And we're doing that, again, we're going to do it parametrically. So this is my radius again. So that radius, I'm pulling from right here, that 23 inches. Okay. 23 inches. All right, and then I'm going to do that again. But this one, I'm going to make equal to the top one, so that if I do decide to change my radius on this top one, let's say somebody says, no, 23 doesn't sound right. That's not really what skateboarders use. I might, maybe it's a flatter board and I change in and I put 25 in there. Okay. So, but my measurement was 23, and you can see that it actually changed here the other measurement automatically, because we put the equal sign in. So make sure as you're going through, if I put it equal to another one and you see that FX pop up right there, you put that FX in there, because you need to make sure that that is in there. Okay, so this one is dimension. Like we know that it's 0 from here to this point. We know that it's 0.5 there. And so that changes the thickness of it. And then we also know that these radiuses are 23. Okay, so we're gonna extrude our first part of the board here. So we're going to hit extrude, and the distance that we're actually going to extrude, so if you look back over the drawing, we are going to extrude the distance, half of the distance from here to this first plane right here, because this is, we're going to put a plane in after we extrude it to get to this next line, okay, which is actually a different shape in the board. But this one is pretty much the same shape throughout the board. Okay, so to do that, I'm actually going to put a little math into Autodesk Inventor. So you're going to have to bear with me. There's no measurement in here that I measured from here to here, or in this case, from here to here. But I did it through, say, some math. And I have this measurement ended up being 25.5 inches. Okay, you can see that I changed it and then changed it back and then changed it again. And it was based on how long I got for the total board. But just know that I have 25 point here from the end of the board to this, 24 from the end of the board to this one. So what we're going to actually do is take the 24, okay, I'm going to take that 24 and we are going to subtract the 6.5 from it. Okay, so we're going to say 24 minus 6.5. And so that's that kick part, right? Or from where the last of the trucks is. And we really want this distance from here to here, right? But you'll have to believe me on this one. I want to divide that by 2, all right? So I'm going to do 24 point and then subtract this kick out of it and then divide that by 2. And what I've done is I'm making half of it. Like I said, we're going to go from here to here. And the reason we're going to do that is because we're going to mirror it later on, but we're going to get to that later on. So we're going to hit enter. And so now I've got the first section of my board created. Okay, so I'm going to pull that guy over. Then we're going to make another sketch. And this sketch is going to be super fast, unlike the last one. And I'm going to stop with the explanations on the parametric and like equaling. You just have to follow along, okay? Because I don't want the video to be forever. So we're going to start another sketch here. And this one actually gets a little bit easier because we're just going to project the geometry of it. We want to just make sure we can borrow that geometry. Let me finish that sketch. That sketch is done, okay? And then we're going to make a work plane. Okay, so we're going to make a work plane offset. So we're going to offset from this one, and we're going to offset it this distance right here. So the 6 point between these two lines. And you can see, if I do my math, 6.5 minus 5, that would give me a distance of 1.5. And if you don't believe me, you can always enter in, like maybe you got some like really fine measuring tools, and you were able to get closer than half an inch of accuracy. So I just went with kind of the nearest quarter inch, nearest half inch, and this is what I got, 6.5 to 0.5, and that should actually give me a plane that is 1.5 from the other one. All right, so now we are going to start another sketch on this plane. And so if you look at a skateboard, as it goes from the curved section to a flat section here, the board actually transitions through a flat section right there. So if we cut that board right there, it would actually give you a flat section right here. This is flat. So to represent flat in an Autodesk drawing, you do one of the simplest shapes, which is a rectangle. Okay. And so I do my rectangles off of the drawing. And the reason I do that, again, is because I want to put my own measurements in so that once it's measured up, once I know that, because I know it's wrong right now, and once I measure it to something else, I know that my measurements are correct. Okay, so I'm going to hit constrain, and I'm going to hit that measurement there, and it should line up exactly, which means there's a distance of 0 in between them. Okay, so we're going to hit dimension, didn't have to do that again. All right, I'm going to hit a 0 there. So now I know it's lined up on the sides, right? I know my dimensions are lined up. And then the next one we're going to do is, we want to do this kind of somewhat parametrically. And so we are missing some of the numbers that we're going to need for this sketch. So we can do that by making visible the first sketch that we did, so we can pull those measurements from it, or we can just project geometry of that particular line to our drawing. And now when we make that measurement, we can pull it off of here, and it's going to say, yeah, this is going to be over constrained, and we are okay with that. We are okay with not being able to change 0.5 here because it's getting changed in the middle if we want to change it. So now we're actually ready to put in our dimension of how thick the board is. And yes, could you put 0.5 in here and make it right? Well, yeah, but we don't want to have to go back and change that number, and we won't if we follow what I've done there. All right, so now we're ready to actually make a measurement, and we want to borrow another, we want to not borrow, but we want to use information that we already have in there. So we're going to take the bottom of that curve. Okay, we're going to project that geometry, and we're going to measure this guy to the bottom of that curve. And you can see that this one, it looks kind of funky. It's pulling from the radius of that curve. Even though that this is a flat line, it's pulling from the radius of that curve. And we want to match that radius, right? So we are going to get the measurement of that radius. It's going to say you can't change that, and you're right, we don't want to. We want it to change from the beginning, so we're going to say equals this guy right here, P14. So now those match up. Okay, so we're done with that sketch. The next thing we're going to do is we are going to actually create a loft extrusion. Oh my gosh, I'm not used to the smaller screen. Loft, there it is. Okay, so loft extrusion, and to do a loft extrusion, you have to have two sketches. You're basically going from one shape to another. So we're going to select the sketch 2, and we're going to select sketch 3, and you can see it's green. It's given us that it's going from that curved shape right there to the flat shape. And now we hit OK, and you should be able to see that there's our original curve shape, and then there's our flat shape there. All right, so we are really a couple sketches away from being done with the major part of the skateboard. We are going to start off with another work plane. Okay, so we're going to do a work plane offset, and this time we're going to offset from our last sketch, and we're going to do that one. If you look back at the drawing over here, we're going to do that one 5 inches. So we're going from here to here for our sketch. Okay, so we're just going to put in 5 inches there, and then we're going to start a sketch on that plane. Okay, so again, I like doing my rectangles. We're going to just do another rectangle. This is actually flat in the skateboard. So I like doing my rectangles off and wrong to start with. That way, when I dimension it, it becomes correct. And we're going to steal our geometry from the other one. So we're going to hit project geometry. We're going to hit that last rectangle. And then we are going to be able to pull from that geometry now. So we're going to hit dimension. We're going to dimension that last. We're going to dimension that last one from here to here. 0.5. We're okay with it being constrained. And down. We're okay with it being constrained. And now we're going to dimension our rectangle here. So that one should equal my 0.5. Okay, again, it's going to change it automatically. And then we're going to hit equals this guy. And so now my width and my length are correct. Now we just got to get it placed correctly. And again, I like doing them off of and wrong so that when I go back and I put 0 in here, I mean, there's other ways that you can do it. I just like the numbers, man. I like putting the number in and knowing that that is 0. And now we've got to figure out how high to make this from our bottom line. All right, so if we look at it from the side, oh no, oh yeah, okay, so we're good. This up here, this F5 up here, this little line up here, this is where our kick is going to loft to. So we need to figure out what the distance is from here to here, or here to, yeah, so from here to here, like if you had a triangle. So the way we're going to do that is we're going to look down at my, trig down here. Okay, the original measurement I came up with for my angle of the kick was 157.5. So if you try to use trig on that and you put in 157.5, you're going to get out a negative number. And the reason I got a negative number is because I was using the inside angle and I was calling that 157.5. This angle is not 157.5. This angle is. So to figure out this angle, you're just going to do your 180 minus 157.5 and you get 22.5. So I redid my trig function as, I'll just write it out real quick so you guys can see it. I redid my trig function as tan of 22.5, and then tan is opposite over adjacent, so of x. So that was this x right here. So I was looking for this distance from here to here. So I did my x there, and I knew that this length from here to here was 5 inches. So I've got my triangle right there, right? And I did over 5. So I did follow the math in the trig function. If you need help with that in class, I don't really want, this isn't really focused on trig, so I'm not going to focus on that. But the measurement I ended up getting was, sorry, maybe I am going to do the trig function, 2.07 inches. So x equaled 2.07 inches. And I am rounding to the hundredth of an inch right there. And so now I'm actually ready to go back into Autodesk Inventor and then dimension this from the bottom, and that should be 2.07 inches. All right, I'm ready to finish my sketch. Okay, so we're going to do another loft extrusion. Again, loft requires two sketches. Oh, wait a minute. And so that means I've got to go back in and do my, I got to do a new sketch on the last plane. And this one is a super easy sketch. This is all we're doing is copying that geometry. Okay. And now we're ready to do a loft. Sorry about that. I'm trying to get this done quickly so that okay. So sketch 5, sketch 4. Oh, we need to select which one we're going to. I was confused about that. There we go. All right, so now I've got my kick. Perfect. So we're almost ready for hole placement. And before we do hole placement, what I'm going to do is we're just going to modify this guy. And we are going to go into extrusion 1. And we're just going to hit visibility. And that makes this last one a little bit easier. Okay, so, and we're looking for the width of this board on this one. And you'll see why in a second. We're going to hit our fillet tool. And we're going to click on these two corners. So we want these edges to be the same radius as obviously half the dimension or half the diameter of our board. So we're actually going to take and make an equation in here. We're going to take this guy, this 0.75, and you can see how it's like crossing over here. And that's not really what we really want. That's because radius is half of the diameter. So we're going to put in half there, and now that's looking a little bit better. All right, so now we have half our skateboard. Okay. Oh man, we're like at home plate here. We are almost done. Once we do that, we can actually start a new work plane, and this time, instead of a work plane that is built on another plane, we're going to do two coplanar edges. So click on that one, and the two edges that we're going to do is the top edge and that bottom edge. And it's going to put a plane that goes across the top of our board. So if we look at this from the side, you can see that we just added this plane right here. And we're adding a plane in there for the holes of that skateboard. Okay, so we're going to start a new sketch, and we're going to start it on that plane. And then we're going to put some circles in there. Okay, and I'm just going to do random circles. Again, you know, there's a million ways to do these. You could do the pattern tool. Some of my students haven't gone through IED, so they haven't seen the pattern tool. They just went through POA and jumped in this course. So I'm just going to show you the kind of the quick way of doing this. Again, Autodesk Inventor is an extremely powerful tool where there is multiple fast ways of doing things. So we're going to go with an 1/8 inch hole here. It may not be exact if we get to our skateboard and we're drilling the hole and we try to mount our the trucks on the bottom of it, and that hole's too big, too small, then we can always drill out a bigger hole. But we're going to start with an 1/8, and we're going to make sure that all of these other holes are dimensioned at an 1/8. Okay, and you can see how that FX is popping up. I'm doing this parametrically, right? So if you change one hole, you're going to change all of the holes. And I don't know if I mentioned that the holes in my drawing up here, those holes are lined up on this very first plane where that first section of the board ended. So that's why I'm doing it on this particular line right here. Okay, then we're going to get our distances in between the holes. Okay, and again, I like putting all of my measurements in so that we know that they're correct. Okay, we're not assuming that the constraints were automatically put in by Autodesk. We don't have to worry about that. Okay, so you see that I put this little weird equation in here, or like, I don't know if it's equation, expression, I guess. It is just the 2 and 1/16 here. Okay, so just that 2 and 1/16. And then I'm going to hit enter. Oh, no, that was the wrong one, wasn't it? So shouldn't be 2 and 1/16. It should actually be 1. Here, I'm rushing through my video, making mistakes. Okay, so 2 plus 5/8 is the distance going between them. All right. So 1 and 5/8, sorry. And then I'm going to make sure that I copy that distance from the center of this hole to the center of this hole. And we're going to make it equal that. Boom. Okay, so now they're matched up perfectly. I don't have to worry if I change this one, the other one's going to change. Okay, so then I'm going to go back here and I'm going to say this one, 2 plus the fraction. I don't even have to calculate the fraction. You could do the decimal, figure it out. But I just like doing the fraction, putting it in there because I like to let Autodesk do the mathy parts. Okay, so we're going to say equals, and it looks like it tried to make it equal that already, but we want to explicitly tell it that it's a function of the other one. All right, so now we have them spaced correctly. Again, for the used skateboarders out there that know what the measurement exactly is, this is a measurement that I pulled off of the skateboard we're working with. I've read online that it's 1.5 inches. It might be 2 inches here. So you're going to have to just double check that. Your measurement on that one. All right, so next up we got to center these. We've got to center these holes on the skateboard. Okay, but if you put the half of the width of the board in here, so if we take our width of 7.75, okay, and we just straight divide that by 2 to get half the width, the holes are going to be off. You can see that those holes are absolutely off. Even that other one, right? So it looks like we've got some other stuff to fix in here too, and we can come back and fix those later on. So we're going to do this dimension. We're actually going to make it that wrong dimension over here. So now they're the same wrong answer, right? But what we can do is fix our formula. That D3 is correct. That dimension 3 is correct. And we need to make it so that's 7.75, right? And we're going to actually make that a function here. So we're going to say D3, so our measurement of 7.75 divided by 2. Remember that half doesn't work for us. So then we're going to do our distance of 1.65 divided by 2. So we're taking half of the width of the board, so half of the width of the board, and then half of the width of the spacing between the 2 points, and then we hit enter, and it actually pulls it back up that half distance. And we're going to pull this guy back now, okay? So we're going to make that 0, and it pulls it back in line now. All right, so now we're actually ready. We're ready to make those holes. So we're going to use that hole tool. Sorry, there were a couple interruptions here. And we're going to change that to 1/8. You could extrude them, but I'm going to just use the hole tool because it makes it really pretty in the drawing file. When we get to that, we don't have to put certain measurements in there. We just use the hole tool for the measurement in the drawing file. All right, so now we've got our hole placements. We've got the holes in the board. We're actually ready to finish up the rest of the board. And the last step is mirroring. Okay, so I'm going to maximize this so it's a little easier to see. We don't need our drawing anymore. And we are going to use the pattern tool up here, up in the top in the pattern section, and then we're going to do our mirror tool. Okay, so it's important that you select mirror all solids, and we're going to select the mirror plane, and that's just the plane that we're going to mirror over. And you can see that my skateboard is now finished. All right, so now that we have that done, make sure you save it. Rewind the video, go slowly. If there was some parts that I went too slowly for you, then fast forward through that. But please, 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 if there is a function that if there was a measurement that I was basing another measurement on, you really need to do that. Pay attention to those in this video, because if you don't, your mold of your board will not turn out correctly. Okay, so make sure that you follow the steps step by step. If I do something, you do something. Stop the video, do it. If I do something, stop the video, do it. Okay, but that's how you make you're going to make your board in Autodesk Inventor. So I appreciate your time, and if you have any questions in class, good luck.